Hey everybody, welcome back. Another Tuesday Tech Talk. I know we're running a little behind on this one this week. It's been a busy week. I'm actually trying to shoot this now in the morning before things get started. Hopefully the phone doesn't start ringing. Last week we looked at small drivers, mid-bass drivers, woofers, and we discussed different options and things that are available, different cone materials and things like that. This week we're going to go to the upper frequency range, and we're going to talk about high frequency selection a little bit and some of the differences between some of these options that are available out there, different types of tweeters, what their strengths are and what their weaknesses are. Let's start with the ribbon tweeter. Had some requests about this. This is one of the RM Cantus ribbon tweeters. We did several kits using these tweeters. I think we went through about 250 of them with the Criterion and Delucio kits. And I used to be a distributor for the Raven ribbon products many years ago. So very familiar with the ribbons. What the ribbon is a suspended element. It is a very lightweight aluminum piece, and it's suspended on the top and the bottom is where it's connected to where it's making conductivity. And there's huge neodymium magnets that are on each side of this thing. So what we've got is we've got a suspended element and then a huge block of neodymium magnet that's got a high concentrated field strength on either side of it. So it's suspended within the gap. Now, there's pros and cons to this type of tweeter and this type of design. Pros, it's very lightweight, extremely lightweight, and very fast, as are the other types of ribbons out there. Rawl makes some of them. Theirs is an unfolded ribbon. It's not creased like the RM Cantus ribbon, and it's just a taut, stretched ribbon. But very lightweight, very agile. It captures the trailing edge of instruments really well, like the crack of a cymbal. That decay is captured really well by the ribbons. Cons, they don't play down very low in most cases. This one would play down to a crossover point of about 2500 hertz. That's it. You just can't force it down much lower. If you let it get down in the lower frequency ranges, it'll tend to want to flutter. It'll tend to want to start moving around, and as it moves, it's in and out of the gap. The gap is a focused field strength, so as soon as it starts moving, it's out of that field strength, so to speak. So it loses control quickly. Kind of like the old Apogee speakers. They had long suspended element ribbons, and if you played them very hard, you notice they just start swaying in and out. They're just in and out of the field, losing some control. That's common amongst those things. They're also very, very fragile. So if you were to just blow on them, you can see the element moving. It's, just gently blowing on it. It's very fragile. If you were to just on it like that, you would stretch it out, and you'd have to go in and retension it or replace the element. The elements are replaceable when they're damaged. You can take these things out. You can drop another one in. You have to use plastic tweezers. If you use a metal tweezer, it'll just suck right into the gap. So you have to be careful, and it's called optically aligning. So you look at it and line it up and get it straight, and you hope that you kept the same tension in it. As you change the tension in it, you're changing the sensitivity. So very fragile. I've had customers with these that told me their wife was vacuuming, and she put the attachment on her vacuum with a little brush on it, and she's cleaning over the front of the speaker, and as soon as she wiped across the tweeter and sucked the dust off of the faceplate, it just sucked the element right out. So very fragile. And I've had guys try to put them in their cars. They don't last long in car audio. As soon as you roll the window down, going down the road, the wind to tear it up. I even remember there was years ago that Legacy Audio used some of the ribbon tweeters in some of their models, and it was featured on the cover of the Absolute Sound. And if you look at that cover, you'll see the element of one of the ribbons is folded over against the front of it like a little wet noodle. It's the equivalent of a blown tweeter in the speaker that's on the cover of the magazine. That was kind of sad. So yeah, they're very fragile. They don't really capture the attack really well like other drivers do. The raw's not too bad. They have an OEM version that's pretty good, but they typically don't really capture like the crack of a cymbal, but they capture the decay really, really well. Comparison to that, or in comparison to that, are the planar magnetic tweeters. This is one of our planar magnetic tweeters. It is very different in the way it's made. I have one that's apart here. You can see the metal frame has neodymium bar magnets, and there's neodymium bar magnets on both sides. This one is taken apart so you can see the diaphragm. There's an etched film that runs back and forth on here that's a conductive material that makes what you'd think of as the voice coil. That's what the actual current is being sent through. It's a thin line, and the width of it versus the length of it makes the appropriate impedance. This one is sandwiched on a material called Caladex. Caladex typically has a yellow tint to it, and it withstands temperatures a little bit better than most films. The BG drivers that were used years ago, like these, have a Caladex film, so it's a white or clear film versus the Kapton that tends to be a little yellow, but very similar. Our driver's made very similar to the BG driver, other than the film and the pure copper terminals that are gold coated. The advantages of, the field strengths are really strong in these. You have to be really careful handling these in this open form. The advantages of these things: they're super rugged. They'll play down really low, and they'll handle really good power. I could literally take one of these things and throw it down the street and let it bounce off the sidewalk, pick it back up, hook it up. May have a few scratches on it, but it's tough. It won't hurt it. This membrane is stretched tight across the magnets. It's very durable. It handles power well. It's a great choice for a lot of applications. The advantage is, of course, playing down really low. It's relieving the small driver more quickly of being able to play those upper ranges. So instead of, for instance, you may have a dome tweeter that, this one we typically cross around 2,000 hertz. Whereas the planar magnetics may cross at 1,500 hertz or 1,800 hertz. So you're more quickly handing off to a faster, more agile driver. So you're gaining speed, detail, resolution, things like that more quickly, because in a lot of times you're not comparing this tweeter to that tweeter, you're comparing this tweeter to the woofer that's used with this tweeter, because the woofer's having to play up a lot higher. So there's a lot of advantages in the planar magnetic. Also, you can load these into a waveguide. We use ours loaded into a waveguide that allows it to play a lot lower, and we cross as low as 1,300 hertz. So huge advantages in that regard when you start talking about placing them in a waveguide. These are some of the BG units. This is an early unit. It's an early faceplate, and it had a shallow back cup on it. And then they went to a deep back cup, and this was only available to OEMs for a long time. We were using them in all of our models. When you put a deeper cup on it, it unloads the diaphragm, whereas the shallow cups, as a shorter airspace, smaller airspace, tends to load the diaphragm, tends to allow it to play flatter and then have more of a knee. Whenever you have it in a deeper cup, it unloads that diaphragm, allows it to start rolling off a little earlier, but it has a nice, smooth, gentle roll-off. The other big advantage to the planar magnetics is put them in an open baffle. When you can remove the back cup on them completely, put them in an open baffle application, wow, they get really transparent, really open sounding. There's no load on the diaphragm at all, and boy, do they sound good. Really clear. They'll play down really low. Man, they're a whole different tweeter depending on how you treat it. As soon as you put it in that open baffle application, wow. This one is the BG Neo 8. This is actually a custom Neo 8 that we had built for us that we use in some line sources. It has the PDR technology on the front side, but not on the back side. All 5 rows of magnets. So it's keeping high sensitivity, and but it's keeping a wide dispersion. So it's really only playing through the holes here in the center, the 2 center holes, which is about 5/8 of an inch wide. And the smaller the diaphragm, the wider the dispersion. As soon as the diaphragm starts getting bigger and bigger, the dispersion is more limited. Now, we use these in a line source where we had a whole line of them, and they work great in that application. If you just use one as a single tweeter, the limitation is the height of the tweeter. So anytime any driver at all is playing any wavelength of where the wavelength is shorter than the length of the diaphragm in any direction, it's going to beam. What I mean by beaming is it's going to play like this at the higher frequency ranges. As soon as you get above it or below it, you're not going to hear those frequency ranges. They're just going to start dropping off. So you have a very limited window when you're trying to use a tall tweeter as a single tweeter. Same goes for this big monster here. This is the Bama Amt Tweeter. The Amt Tweeter is a little different in that the conductive elements run up and down this way, and the motion that they go through is side to side. It's a little different technology. Typically they don't play down real low. This one is huge and has a tremendous field strength. These are huge neodymium bar magnets. So this one, because of its size, actually will play down pretty low. In this form, it'll play down to about 2 kHz. And there's waveguides out there that you can mount these in that will allow them to play down to almost 1 kHz. But again, the height limits the range. So you have to be seated within that range in order to hear the high frequency. As soon as you stand up, it's all going to fall apart. It's going to fall down. And the room response could be a little uneven because of it. So you're not getting your wide dispersion there, so your floor and your ceiling reflections and things like that are not there in those upper frequency ranges. Could be a plus, could also be a negative in that your total room response may look soft on the top end because you're gaining room reinforcement or reflections in those lower ranges, but you're not in the upper ranges. So pros and cons. This one also has a removable back, and we've used it with the back off, and very much like the planar magnetics, as soon as you remove the back, you unload the diaphragm a little bit, and it sounds a lot more open, a lot more transparent. So keep that stuff in mind when you're looking at that type of tweeter, as opposed to dome tweeters. There's a lot of dome tweeters out there. Things I like to look for, a deep cup on the back, like the one on our T26 SG, and the wave core has a cup on the back also. It has a large hollow pole piece. Same with this, large hollow pole piece. It unloads the diaphragm, so it allows it to sound a little more relaxed. That's something I like to look for. I like the soft domes, and they have a nice forgiving response typically, a nice smooth sound. The metal tweeters, like this aluminum dome, this one's a TB driver. It has the advantage of its small size. You can get it mounted closer to what you're crossing it to, so you get closer center to center, so that's an advantage. But typically metal cone drivers have some type of a resonance or a ring, usually at the very top, and sometimes that can get really annoying or really harsh. Some people don't really notice it, they don't hear that high. Some people hear it immediately and it just gets on their nerves, it becomes harsh. So those are things you really need to look for when you're looking at metal diaphragms. It is stiffer. A lot of people say, well, stiffer is better, but not necessarily. When you're listening to it, it could have a tingier sound to it, harsher sound a lot of times, and this is a generalization. And there's diaphragms out there that you'll see like beryllium, and there's a little misconception out there when you see some of them that advertise as beryllium. Not all of them are really beryllium. Some of them are just aluminum diaphragms with a light beryllium coating. You can tell the ones that are true beryllium when they're usually more expensive, and they're going to have a complete screen over the front. The reason you see them with a complete screen over the front is if you were to reach in and touch it, it would likely shatter, and the dust particles that come off of the beryllium are actually toxic. So they don't want you touching it. So there's going to be a screen or something across the diaphragm when you see a true beryllium being advertised. And I have a freight truck pulling up. So we're going to pause and come back. Ron, you're just going to have to do a little splicing. Okay, last point, dome tweeters. The dome tweeters can be different diameters. The smaller the diameter, the wider the dispersion. Like some little hickathon tweeters, they're only like 5/8 of an inch in diameter, or 1/2 inch in diameter. So the off-axis response is pretty good because of how small the diaphragm is. As the diaphragm gets larger and larger, it's going to have limited off-axis response, but they're still fairly small, so they're still going to have pretty good off-axis response, even though the diaphragm has gotten pretty good size. But the bigger diaphragm tweeters also tend to play down lower. Look at the FS of the tweeter. That'll tell you a lot about how low it'll play. These diaphragms are the same size, but the damping material, or the rear damping, is not the same. This one has almost no chamber, has a neodymium magnet. This one, using almost the exact same diaphragm, probably if not the same diaphragm, has a ceramic magnet, but a big cup on the back and a big open pole piece, and the FS is a lot lower. So this one is capable of playing down a lot lower, even though the diaphragms are the same. So keep those things in mind. And then as you get back down to 1-inch tweeters, a lot of them still, because the rear chamber is so large and so well damped, the diaphragm is well damped, it has a low FS and it's capable of playing down really low. Tweeters like our GRT3 has damping behind the diaphragm, but not deep like that one. Its FS is higher, around 1100, limited to about 2000 hertz and higher on the crossover point, so keep that stuff in mind. This one has a deep chamber that helps it out quite a bit. It's still neodymium motor structure. There's a lot of this stuff out there. You're just going to have to look at the parameters and look at the application to decide if it's right for the application you're wanting to use it in. If you have questions about an application, and we get these a lot, email them to me. Don't write a book. Please don't tell me about your whole audio history. Just ask me the question and I'll give you a quick answer. So that's the easiest way for me to respond to you guys. I know you guys also like to put a lot of information in the comment section. Same there. If you have a question or a comment, drop it in the comment section. I appreciate you guys responding. I love all the thumbs up, and the views that we're starting to get on these are really good. Be sure and share them with your buddies and your forums, and copy and paste the URLs and pass this stuff around. I'm trying to do this on an educational basis. I know I've used some of our own products as examples. That's kind of what I have at hand, especially when I start getting into kits. Just what I have on hand to use as samples. That's what I've got. That's it though for this week. If you have anything, let me know. Thanks for viewing. See you next week.